Hello, grade 4 students. Mr. Waterman here with today's mathematics lesson on Wednesday, September 8th, 2021. I hope you all are doing safe and well and you have had a great morning studying so far. Today, we are going to start a unit on tessellations. So you know we have been talking about shapes and transformations the last couple of weeks. So now we're going to go into tessellations. And I have the textbook here. I'm going to explain and go over some examples with you. And then after that, I'm going to show you the activity that is in your practice book. It's not in your homework book this week. It is in your practice book. And don't worry, you'll have the PDF to access it when you're ready to complete the activity. So I wanted to put myself in front of the camera because I am filming from my iPad, as many of you know, and we don't have that split screen feature. So, hi, I haven't seen many of you in a long time, and I hope to see you all very, very soon. All right, let's get started. I am on page 476 in the textbook that we use. And this is going to lead to an activity which we are going to start next week. So the title on our page here, it says, I see a pattern. Okay? Take a look at this picture behind the title and this little passage here. What do you see? Do you see bees? And if you can see the bees, where are they? Do you know what this is called? If you said honeycomb, that is correct. And do you know where this is? If you said inside of the bee's hive, that is also correct. What does a beehive have to do with our math lesson? Well, let's read about it and find out. I see a pattern. Please listen carefully as I read and feel free to read along. When the same shapes are repeated over and over, they make patterns. Think about the honeycomb in a beehive. It is made up of repeating hexagons that form a pattern. Repeating patterns that completely cover a region are called tessellations. Tessellations have no gaps and no overlaps. Okay? So they have no gaps or overlaps. As you can see here in the honeycomb, these are the hexagonal shapes here. And they are all next to each other. There are no gaps or overlaps. Okay? Now, we're going to read about one of my favorite artists of all time. I think many of you have even heard of this artist. His name is M.C. Escher. And this is one of his works here. M.C. Escher was a Dutch artist who drew tessellations. He often used animals, such as birds, fish, and lizards, to create complex patterns. The picture at the right is one of his works. It's called Unicorn by Moritz Cornelius Escher. And this was done in 1950. Let's pay close attention to the pattern here. It's really interesting, isn't it? Now you can see the unicorns. You can see that they are different colors. How many different colors do you see? It looks like he's working with gold, silver, and red. There you go. 1, 2, 3. So he has used 3 different colors, but you can see that the unicorns, the patterns repeat, but there's no space between them. It's really interesting. It almost looks as if the unicorns are standing on top of one another. Such a brilliant piece of work. Do you think you could try to do something like this? You're going to get your chance next week. Let's go to page 477. And don't worry, both of these pages will also be available as PDFs for you. This is our problem solving. This is figure A. Take a look at it. It says to use the design above for problems 1 and 2. Please listen carefully and feel free to read along. Gina is tiling her hallway. She repeated figure A to make the tessellation above. What geometric shapes are in this tessellation? List all that you can find. Can you find them all? Well, before we answer the questions, I have my trusty notebook here. And remember, even if you don't have your notebook, you can use your own notebook paper. And when you come to school, you can glue this in your notebook. Okay? So I am going to be working on page 12 today. Tessellations. Big word. Tessellations. Tessellations, page 12. I'm going to write my page number here again, and now I write my title at the top. Tessellations. Okay, so you know we always write an objective, right? So my objective today, our objective today, is going to be to learn about tessellations. Okay? And the first thing I'm going to do here is I'm going to write what a tessellation is. So a tessellation is a pattern of one or more identical, that means they look exactly the same, identical shapes, S below the line like that, fix that, there we go, shapes that fit together without any gaps or overlaps. All right, there's our meaning. So we are going to look at some of the examples here, and I'm going to write problem solving, textbook, page 477. Okay? And I'm going to copy exactly what I see here. I'm going to move that to the side so you all can see the notebook. Now I can write my questions. 1. Gina is tiling her hallway. She repeated figure A to make the tessellation above. What geometric shapes are in this tessellation? Then it says list all that you can find. Okay, so now I'm going to bring the textbook back. Look very closely at figure A. What geometric shapes can you see? I know that I can see at least 3. Can you see the 3 that I can see? Let's count together. That's 1 geometric shape. That's a rectangle. Here's another geometric shape. That is a square. And here is yet another geometric shape. That's a triangle. So we can write these down as our answers. So I'm going to say I can see triangles, rectangles, and squares. Because when you put these triangles together, they make a square. Pretty cool, isn't it? Let's look at question number 2. I'm going to move my textbook again. I'll skip a line and I'll begin writing question 2. What transformations do you see in the design? So it also says you can use tracings to explain. Okay? All right. Now, I'm going to move my textbook back. So remember, we already studied the types of transformations. They were reflections, when we draw it facing the opposite way, translations, when we move it, and rotations, when we draw the shape after it has been turned clockwise. Let's look at what transformations we can see. If you're having a difficult time seeing the transformations, you can use paper to trace over them to help you. It's a little difficult for me to trace because then it's going to mess things up for me in the camera, right? But here's what I can tell you. If I move it in, let's take a look at this triangle and this triangle. Okay? Side by side like that. We know that is a reflection. That's the mirror image. So that's one transformation we can see. Now, if we look at this triangle again, and if we look here at this triangle, we know that that's a rotation. It has been turned clockwise. So that's at least two types of transformations that we can see. Can you see the third one? I most certainly can. Take a look at the square from here to here. That's a transformation or translation. We've moved it. So the translation here, it moves to the right. The translation here, it moves down. Okay? So now I'll bring my notebook back. And for my answer, I can say the transformations I see are reflections, and I'll underline that, rotations, I will underline that, and transformations. And I will underline that. So there's our answer. Now, let's have a look. So for number 3, it says, look at the translation. Oh, sorry, look at the tessellation at the right. So that's figures D and E. Take a hard look at it. And now let's write the question out. I'll move my book. Please follow along as I write the question. I'll skip a line. It says, look at the tessellation at the right. Does figure E show a rotation, a reflection, or a translation of figure D? So you can pause the video. If you're taking notes, you can pause the video and you can continue writing to the question. I'm going to move the figure back. Okay. Now take a look. This figure D. Here's figure E. What do we see? Is this a rotation? Well, not exactly. It's not turning clockwise. Because if it turned clockwise, it would look something like that, right? Is it showing us a reflection? I would have to say yes. This is the mirror image of itself. Or is it showing us a translation? No, well, if it were a translation, it would just move but it would look the same. So, for our answer, I'm going to say figure E shows a reflection of figure D. And I will underline that. And there you have it. These are our notes for today. You can pause the video to finish copying. We're going to leave questions 4 and 5. We may discuss them in next week's class. Now, I want to show you the activity you're going to complete. If you happen to have your practice book, it's in here. Okay. And you have to look for where it says Tessellations, which is on this page here. And I'll go through the directions for each part with you. Okay? Now, please remember, a tessellation is a pattern of one or more identical shapes that fit together without any gaps or overlaps. For part 1, do these shapes tessellate? Write yes or no. Let's look at example A. Does this tessellate? Look closely. Yes, it does. The shape continues. There's no space or overlap in between it. Yes. Let's look at example C. Does this tessellate? I'm going to say the answer here is no. There are spaces in between, and you can see the overlap, right? Now look at part 2. Do these shapes tessellate? Write yes or no. Let's look at a few examples. Let's look at a different example this time. Let's look at B, this triangle. Does this tessellate? Yes, it does. We know from the example that we looked at in the textbook. Yes. Okay. Let's look at one more example. Let's look at example D. What shape is this? 1, 2, 3, 4, 5. So we know a pentagon has 5 shapes, but a pentagon is not going to tessellate. There are going to be gaps in between it, right? So we're going to say no. Okay. Part 3. It says to continue the following tessellations. Okay. So when you are continuing the pattern, I'm going to turn it this way. Okay. You can continue the pattern all the way across. Okay. Just continue the pattern all the way across, just like I did. Okay. All right. Part 4. It says create tessellations using the following shapes. you want to use this shape and then you can begin to create your tessellation. This should be a little bit bigger, okay? You can do it across, you can go down and across. We'll see what the finished product looks like next week. For part 5, it says to draw a shape that will not tessellate. And for number 6, it says to create your own tessellation pattern. And that's it for these activities. Remember, look at the examples we saw in the textbook today. They don't have gaps or spaces in between, and they don't overlap. Use this to help you with number 6 when you create your own tessellation. Now, take your time with it. Enjoy the activity and have fun. Don't worry if you make a mistake. You could always start over. Okay? The last thing I'm going to do is I'm going to go over the answers from last week's activity, movement of shapes. And I should have did this in the beginning. Okay? Now, for us to save some time, I'm going to put my key up here. Give me just a moment. If you're checking your answers, here's the key. And that's what it should look like from last week. And you can pause it to check your answers. Some of you have already sent me your homework. Now, if you have any questions, feel free to email Mr. Waterman at any time. Don't forget to complete this activity. And if you are sending it to me by email, take a picture of it, send it to me by email, and then I will check it and give you credit for it. That's all for today. Don't forget to put your name at the top. Taejin Lee, and then you'll need to put your class and your color group. If you're orange, write an O, or if you're blue, you'll write B. And that's it. I will come around to say goodbye. Thank you, students. I hope you enjoyed today's lesson. I know the video is a little bit long, but I don't think that you guys will have any trouble doing your homework on this page because we had a lot of examples. Take care, stay safe and well. Enjoy the rest of your day studying. Hopefully, we will see each other very soon. You can come to school and we can study math together. Bye-bye for now.